Section 5.9 deals with hyperbolic functions. The unit hyperbola x squared minus y squared equals 1 is used to define these hyperbolic functions. Hyperbolic functions have many similar characteristics to circular functions, so trigonometric functions, and hyperbolic functions are actually defined based on exponential functions. So here's the definition for hyperbolic functions. We say that the hyperbolic sine of x is equal to e to the x minus e to the negative x all over 2. The hyperbolic cosine of x is equal to e to the x plus e to the negative x all over 2. And the hyperbolic tangent of x is equal to the hyperbolic sine over the hyperbolic cosine, or e to the x minus e to the negative x divided by e to the x plus e to the negative x. The hyperbolic cosecant of x is equal to 1 over the hyperbolic sine, or 2 over e to the x minus e to the negative x, and that's where x doesn't equal 0. The hyperbolic secant of x is 1 over the hyperbolic cosine, or 2 over e to the x plus e to the negative x. And the hyperbolic cotangent of x is equal to the hyperbolic cosine over the hyperbolic sine, or e to the x plus e to the negative x divided by e to the x minus e to the negative x, again where x doesn't equal 0. Now, the hyperbolic cosine, the hyperbolic sine, and the hyperbolic tangent are actually programmed into a calculator, and I'll show you how to find that on a TI-84 or a TI-83. So you don't need to have these formulas memorized. Also, instead of saying hyperbolic sine or hyperbolic cosine, etc., a lot of times you'll just hear sine h, cosine h, tan h, cosecant h, secant h, or cotangent h, so that there's less words to say. So from here on out, we're just going to call them the trig function h. So sine h, cosine h, tan h, cosecant h, secant h, cotangent h for those hyperbolic functions. Now let's do examples 1 through 3 where we're actually just using these formulas to find the value. So if we want to find the cosine h of 2, well, we know that we can use this formula e to the x plus e to the negative x all over 2. So in this case, we could say that this is equal to e squared plus e to the negative 2 all over 2. And if we were to put that into a calculator, e squared plus e to the negative 2 divided by 2 to 3 decimal places would be 3.762. So this is approximately 3.762. But as I mentioned before, the calculator has these hyperbolic functions programmed into it. So to get to cosine h, you would hit second and then 0 for the catalog. And since we want to go to cosine h, I'm going to hit C, which is right there, the program key, to get to the C's quicker, and then scroll down till I get to cosine h. I select cosine h and then I enter 2, and notice that you get the exact same value. The next one, tan h of 0, if we do that just on the calculator, again second and then catalog, I'm going to hit the letter T. The letter T is right there, the number 4, and it just gets me to the T's quicker in my catalog. Go down to tan h and do tan h of 0, and we end up with this is equal to 0. Finally, sine h of 1. So second and then catalog, I'm going to hit the letter S, and the letter S is located at the natural log button, and then scroll down to sine h and do sine h of 1, and sine h of 1 is equal to 1.175 rounded to 3 decimal places. The next thing we're going to look at are hyperbolic identities. You don't need to memorize the following hyperbolic identities, but you'll see that the textbook as well as WebAssign will sometimes clean up their answers using these identities. It's not necessary, but I wanted to make sure I introduced them to you. Now these identities are very similar to the trigonometric identities that you know from a trig class or a precalculus class, but there are a little bit of differences from them. Since it's based off of the unit hyperbola and not the unit circle, we have the identities cosine h squared x minus sine h squared x is equal to 1 instead of a plus sign, which then leads to the other two, tan squared h plus secant squared h equals 1. And then cotangent h squared x minus cosecant h squared x equals 1. Double angle, sine h of 2x is equal to 2 sine h cosine h. Double angle for cosine h of 2x is equal to cosine h squared x plus sine h squared x. The sum and difference identities, sine h of x plus y is sine hx cosine hy plus cosine hx sine hy. Sine h of x minus y is sine hx times cosine hy minus cosine hx sine hy. Cosine h of x plus y, cosine hx cosine hy plus sine hx sine hy. Finally, cosine hx minus y is cosine hx cosine hy minus sine hx sine hy. And finally, these power reduction ones, sine h squared of x is equal to negative 1 plus cosine h of 2x all over 2. And then cosine h squared of x is 1 plus cosine h of 2x all over 2. Again, you do not need to have those memorized, but you will see the textbook will sometimes clean up derivatives using these identities, but it is not necessary. What we're going to concentrate on in this section are the derivatives and the integrals for hyperbolic functions, and then the derivatives and the integrals for inverse hyperbolic functions. So what we're going to do right now is just prove where the derivative of the sine h of x comes from, and then we're going to look at just the rules that you would use to find the derivatives. So by definition, using the formula above, this guy right here, we could find the derivative of f of x equals sine h of x. Why? Because we know that sine h is just equal to e to the x minus e to the negative x over 2. Well, the first thing we realize is that this is over 2, and 2 is just a number, so we could rewrite this as 1/2 times e to the x minus e to the negative x. And I have formulas to find the derivative of this particular function. Well, the derivative here would be, well, 1/2 is a constant multiplier, which multiplies along. The derivative of e to the x is e to the x minus, and the derivative of e to the negative x is going to be negative e to the negative x, because it's e to the negative x times the derivative of negative x, which is negative 1. Well, those two negatives make a positive, and you have 1/2 e to the x plus e to the negative x. Well, this is just e to the x plus e to the negative x all over 2, which happens to be cosine h of x. So the derivative of sine h of x is cosine h of x.